Okay, 3, 2, 1. So yesterday I created a video that basically give you an overview of what's required to add to the report with regards to LO3 and LO4, which is assignment 2. Today I'm going to go into a little bit more detail. I've had some problems. The files are around 2 gigabytes to 3 gigabytes, and for some reason it just won't let me airdrop them. So what I've and I think that might have been the problem before, so I'm sort of changing them a little bit, hence why I think Lucy might have had a problem when I sent them to her a month ago, is that maybe the airdrop didn't send. So I've created them now on YouTube, and I'll put this one up on YouTube and I'll send them as links, because for some reason the forgive me, the this file is so big, my Wi-Fi is not allowing it to go through, even when I convert it to an airdrop on my, obviously, Apple. Okay, I'll check what's going on there anyway. So the aim of this is to explore analytical estimating techniques. Now, if we think about LO3 and LO4, and it's linked to LO1 and LO2 as well, particularly LO1, where you're asked to sort of explain the different rules of measurement. So it's linked to the different rules of measurement, because certainly with regards to the merits and the distinctions, they're asking you why things change over the life cycle of the project, to evaluate it, to analyze it. So you're following these rules of measurement, particularly those ones in NRM1, and you're producing like a cost estimate based on the GIFR, and you're following the rules, or you're producing a budget or an estimate based on the measurement rules for elemental cost plan. Again, you follow the rules to produce an elemental cost plan and with approximate quantities. Using that, you can actually produce, doing some analysis, you can actually produce a more accurate estimate using elemental cost plan, approximate quantities as measured in accordance with NRM1, and then you can create an elemental unit rate based on those quantities. So you get it as you progress. You need more information, obviously, to do that, because you'd start off with your cost estimate based on a ground floor area or a functional floor area. Follow all those rules that are listed in NRM1. And then when you've got more drawings, you've got a specification, more detailed specification, health and safety with regards to a CDM, so maybe a health and safety report. You can then start to produce much more accurate quantities, and as a result of producing those accurate quantities, you can use things like SPONs, you can use things like the BCI database, building cost index database, to then produce an estimate based on your elemental cost plan, create an elemental unit rate based on your approximate quantities. So fundamentally, these are the things that you're asked to write about, and then you've got to show some evidence that you've produced maybe an all-in rate. So what you're moving across to now, when I say all-in rate, what you're actually moving across to now is you're actually moving over to what I would call, or what's called, I should say, in the books, analytical estimating. Now, analytical estimating is where you can still use SPONs as a guide. You can still use BCIS database as well. However, you can start to get some quotations. You can start to base it on certain time and motion studies that have been carried out over the years, which are in various estimating books. What that means is you're analysing and breaking down the unit rate much more to a fundamental level. So you're converting, say, an hourly rate to a meters cubed rate or a meter squared rate based on current studies with regards to time and motion, and also current prices out there. So you get a quote from maybe a material supplier, or maybe you work out your labour costs based on the National Working Rule Agreement. They are the things that you can start to do in a much more analytical, and therefore some would say much more accurate way. And that's really what the questions in LO3 and LO4 are actually holistically are asking you. And you can relate it, as I say, back to LO1, the first assignment. Okay. So if we look at some examples for a minute, okay, I'm going to use my strip foundation model, but it equally applies to the other sort of models that we use, particularly the example that we used for the first assignment, which is the raft foundation. Okay, so we got a strip foundation, basic strip foundation with a large cavity wall and probably 150mm cavity wall to cover modern building regs. Okay, so ultimately the key to producing an accurate all-in rate, because that's what we're talking about, is producing now. We're analysing and we're going to produce an all-in rate, and we're going to write about it. And we're going to explain the difference between an all-in rate, maybe, and an elemental unit rate, or a rate that we've created for an elemental cost plan. Because in theory, an all-in rate is a rate whereby you are producing things based on today's prices. So it's much more up to date. An elemental unit rate, or based on SPONs, or based on the BCIS database, is usually based on historical data, and then you make adjustments in relation to maybe the tender price index or the building price index, those types of things, so in line with inflation. Okay, so it's more of a mathematical exercise. This is a mathematical exercise, but actually it's fundamentally a much more realistic exercise, if you like, because you're breaking everything down into plant or machinery, labour, and materials. Okay, and all the intricacies, the nuances which goes through each of those, because they are broken down. For instance, I'll give you an example. Materials would be broken down into wastage factors. Okay, you might have to convert tons to meters cubed, or meters cubed to meters squared. With bricks, you might have to reduce it to one brick. A price for one brick is £1.50, and there are 60 bricks required, or 59 bricks required in a metre squared. So then you multiply it by 59, and then you add on a wastage figure, something like 5 to 10%. And then the same with blocks, where there's 9.8 blocks in a square metre. You could round it up to 10 metres square, 10 blocks per metre squared. So again, you've got your blocks, and you can reduce it down, a price down to one block, and then just multiply it by 10 or 9.8 to give you a price per metre squared. Okay, so you need all the information at hand. Once you've got all that information, and you've got a little bit of experience as well, because a lot of it's about educated guesses as well. Okay, you can then start to build, for instance, an all-in rate, which, as I said, if I just run through it again: material, plants, labour, and then in addition to that, for each all-in rate, which is basically a rate per metre squared, per metre cubed, per tonne, per number, okay, per linear metre, ultimately they will reflect your quantities in your bill of quantities. That's the idea. So you've produced this bill of quantities, and your rate for, say, a metre squared of concrete, a metre squared of brickwork will reflect basically an hourly rate that you've calculated, and then what we call working back. And we convert that hourly rate into a metre squared rate. And fundamentally, it's about having some historical figures on time and motion. Obviously, the more up to date, the better, because as the years have progressed, time and motion studies show that, or system analysis, if you want a posher word, a more modern word, shows that we are much more productive now. So where maybe a couple of years ago it would have taken, I don't know, 30 minutes to lay a metre squared of bricks. Sorry, not 30 minutes, 2 hours. It now takes about 1.5 hours. So they are the sorts of things that you're sort of looking at, yeah? Okay. And also, fundamentally, we're going to use those sort of time and motion studies with the recognised working agreements, the National Working Agreement, as it was once called. It's the RWA, they call it now. I sort of sometimes use old-fashioned terminology, and that's based on what the RICS, the trade unions involved, the CITB has got together and worked out, this is how much we should be charging, not paying for, but charging for this is how much we should be paying an operative, and we might charge extra. Do you know what I mean? So we might be, the working rule agreement sort of might say that an operative should be paid £20.37 an hour or wherever it is, but actually we are charging maybe the client £30 an hour. Okay. So these are the things that we have to work out, all right? And as I say, so you got your labour, your plant, your materials, and then you would add on a percentage for what profit you want to add, and we'll look at that a little bit later, and a percentage for what overheads we need to add. Okay. So the labour cost and working rule agreement is a booklet. I've sent it over to Lucy, so it should be up on Moodle there. Okay, it's a direct and on the labour rate used, and basically it sort of gives us the rules that we should follow as quantity surveyors. Okay, all right, and it's basically a minimum amount we should be paying for a particular type of labourer, whether it's an operative, and there are different classes of operative, depends on how skilled those operatives are, whether they are semi-skilled or unskilled, or whether they are craftspeople, bricklayers, carpenters, plasterers. Okay. All right. So it includes things that are mandatory employment costs and allowances and obligations. Okay. So it includes your basic minimum hourly rate. Okay. But also then to build that up, we need to obviously include holiday pay, sickness benefit, pensions. And basically what I've done there is how it may be calculated. And fundamentally I've taken that from the working rule agreement, that booklet that's there. So you can reference that, okay, which I didn't reference, to be honest with you. Okay. So you've got your basic wage for a craftsperson, which is £15.83 an hour. But we've got to add on £1.91 an hour because they're entitled to holiday pay. We've got to add on another £2 odd for national insurance. We might add on 3 to 7% for pension. In this case, I've taken it as 3%, which is 48p an hour. We might be charging travel and fare. We might not, but we might. It's fair to do that. And obviously health and safety. So we'll add on something like £1.30 for health and safety, training, insurances. Okay. So when we add all of that up to the basic wage for a craftsperson, we're saying a craftsperson should be paid around £24.64. That's what it's saying in the current National Working Rule Agreement, okay, or the Working Rule Agreement, I should call it, sorry. Okay. And again, then, that's for a general operative. Same principle, just going to be paid a little bit less because they're unskilled or semi-skilled. And sort of, as they move up the as you move up through the scale, they get paid a little bit more because they're starting to become more skilled. Not quite craftspeople, but there's a recognition of the training that they've done. All right. Okay, so that's how you would calculate the labour rate. And if you look at one of the passes there, it's asking you how demonstrate calculating a labour rate. So you can show that and write about it in your report. So add it into your report, explain how it's formulated, and give a mathematical example, because that's what the question is fundamentally asking you, that particular pass. Yeah. Okay, it's for LO3, I believe. Okay, but I'm not 100% sure which pass it is, but it's one of the passes. Okay, and remember, we've got to try and get these passes as well as the merit and the distinction. So what I've done there then, so that's basically that particular pass criteria covered there. Okay, so then we're going to move on. What it goes on then to go on and say, produce an all-in rate for a number of, let's not call them elements, let's call them components, okay, and subcomponents, okay. So, one of the things that you've got is in your bill of quantities, for instance. So if you wanted to price up, for instance, substructure, or you want to price up superstructure, because it's only asking you to price up one section of a bill, I would try and do as much as you can just to show the examiner quite a bit, But if we take substructure, and I give some examples of substructure and I think superstructure here to help you, remember it's a step-by-step process. And it's all about, ultimately, it's all about reading and manipulating a data sheet. So the first step you really need to look at is, what do I actually need to remove a meter cubed of topsoil? Okay, a meter cubed of topsoil. Okay, because it's much easier to price up a meter cubed of topsoil than a meter squared of topsoil. Okay, and then what we can do then, we can then convert it from meter cubed to meter squared, because in the bill of quantities it's going to be a meter squared. All right, so the first thing, what resources do we need? Well, we're probably going to need an excavator, probably a JCB. We're probably going to need a driver with that, and we're probably going to need a banks person for health and safety reasons. Okay, so we don't need any materials, we're just excavating. Okay, and if we really wanted to go into it in much more analysis, we could say maybe we're disposing of it on site. 10 meters, we might need a dumper and a dumper driver, which would be a labourer, probably with an extra skill, so it'd be an operative rate, probably a class 3 or a class 4 operative. However, we can also say, look, we're going to price up the we're going to include the estimate price for the dumper within our preliminary items. So if it's in the preliminary bill, which is your site overheads, and it's the same maybe with the extra labourer as well, by the way, if you're going to do that, then you don't include it within your unit rate. Okay, some companies will put that as part of their unit rate. Some companies will put it as part of their preliminaries. Okay, so in for instance, when I was in Kia's, we would put it in our preliminaries. Okay, however, fundamentally, it's more accurate to put it in your unit rate. Okay, but that that's a rule of thumb. But it doesn't matter where you put it. Okay, so in this case, what I've said is to simplify it, and I think you can say this. It's up to you. Yes, we would need a 1 ton or a 2 ton dumper and a driver. However, they've been priced up separately within the preliminary bill. So we're not going to price them up here. So that's all I need, really, fundamentally, for this particular exercise, is that I need an excavator and I need a driver and a a banks person. Sorry. Okay, and then I'm just going to calculate it then. All right. So we break it down into plant, materials, and labour. We don't need any materials for this one, so plant and labour. Doesn't matter which order you're doing it, but just fundamentally break it down. So, although the driver is labour, I appreciate that, he would be priced up within the plant section because an excavator or even a lorry or anything like that, some big elements of plant which require a driver or an operator would be priced in with those big pieces of plant. Okay, so a driver and excavator, I've just taken this off the top of my head, but you can look at it and find it from the internet how much they cost. So I said it costs £34 an hour. What I've got to do is I've got to convert that £34 an hour into a meter cubed cost. Okay, and what I've done is I've looked at some past time and motion studies, and it takes about 0.15 of an hour to dig 1 meter cubed of topsoil to 150 mil thick. All right, so if it was 100 mil thick, it might take a little bit longer or it might take a little bit less. Okay, so it only takes 0.15 of an hour, however many minutes that is. And if you want to check that, just multiply it by 60. Okay, so that's all I do is I take my hourly rate, which is £34, and I multiply it by 0.15. So it's £5.10 a metre cubed. So fundamentally what we're saying, every metre cubed that I dig, that it takes me to dig 0.15 of an hour, I'm going to be paid £5.10. And ultimately, that's going to cost me £34 in an hour. I also need a banks person because of health and safety reasons. So I've given it the banks person a rate 4 under the CJIC skills rate, the working rule agreement there. Okay, so it's £20.70. The banks person basically might have a shovel, might sort of make tidy things up, but fundamentally is there as a spotter in many respects. Okay. Health and safety, so it's a requirement under the CDM regulations. So he or she cannot work any faster than that machine. So again, you just multiply it by 0.15. So £20.70 times 0.15 gives you £3.15. And that's all you do is add them together. And that gives you £8.20 a metre cubed. Okay. And then what you would do is you'd add on your overheads and profit. So that would be a percentage. So you might say my overheads are around 7%. If you're a larger company, your overheads are going to be much higher than that. But if you're a small regional company, they're going to be anywhere between 5 and 10% maybe. And then your profit's going to be whatever you want as your profit. Again, that's a commercial decision, so we'll call it maybe 5% in this case. So your overheads and profits about 12%. So you'd add on 12%, and then whatever 12% added on to £8.20 would be your final unit rate. Okay, so that's topsoil. Then the next thing we got is this bulk excavation to reduce level. Okay, not exceeding 2 meters deep. We're not going any further than 2 meters deep, and again, in this particular, I've broken it down there for you, okay? All right, okay, but if I look at it in more detail, again, don't forget, first thing, what do I need? Well, again, I need an excavator. I need an operative, a banks person, okay? But I might also need another operative there because this time now I'm digging more. I might need some more help. Okay, and if I wanted to, I could add on a dumper as well with a driver. Okay, so a dumper with a driver, so it would be another operative as well. But I'd need a price per hour for the dumper. And so you've got all of those things there. If you wanted to, but you could say, look, dumper and driver, I'm going to put in the preliminaries. Okay, so this is just for this particular unit rate. So again, my plant, okay, it's £34 an hour. The driver and the excavator is not going to change. Okay, this time is quicker because we're not sort of covering just 6 inches of 150 mil of topsoil. We're going much deeper. So now we can actually use the excavator in a much more ergonomic way. Okay, much quicker. So it's only going to take us 0.05 hours. I've based that on some old data that I've got regarding time and motion studies. And then 34 times 0.05, which gives me £1.70 per metre cubed. Labour, a banks person again, which I multiply by 0.05. And then I've said one general operative. You could say two general operatives, just tidying everything up a little bit, okay? Again, a little bit less because their responsibility is less. Okay, so the banks person in many respects is becoming a bit of a ganger. Yeah, so again, £1.20. Add them all together, comes to £3.76 a metre cubed. There's your all-in rate. Plus whatever overheads and profit percentage you wish to add on. So which I've left up to you. That's why I've not put it there. Okay. This time now you've got, because it's a trench foundation, you don't have this. All right. Although you've got a little bit of a trench, I suppose, but you don't really have it. So, but it's there if you wanted to. So it's a little bit more. I think that you might need some more labourers here. Okay, you might require two rather than one that I've put in there. But these are things I've left up to you because obviously different people are going to have different things. That's the idea of learning outcome 3 and 4. Look, different contractors will and subcontractors will approach you in different ways. Yeah, that's why tender prices will vary. Okay, which is basically what the question is asking you. All right, so it's the same thing. Okay, just takes a little bit less, so it's 0.1 hours. Okay, rather than 0.15. Okay, or 0.05. Sorry, with reduced level. So taking a little bit because it's a trench, so it's much more measured in how we do it. Okay, and fundamentally you build up again. I'm not going to dwell too much on that. I'm just going to move. You've got the topsoil you're going to keep on site. We know that because we're going to use it for backfilling, and we may use it on other sites because we may require it for other sites. Topsoil is worth a bit of money. Okay. However, the subsoil, if you like, which we removed up to around 2 meters, or the trench, okay, we now need to remove it. Now, the maths on this is a little bit more detailed, okay. We're going to use, again, think about it. What I'm trying to say is, what am I going to use? Am I going to use 10-ton lorries, 16-ton lorries, 20-ton lorries? What am I going to use? What's the best for me to use, okay? So what we need to do a time and motion study to keep those vehicles moving. We don't want them on stop. A site manager and a planning engineer will not want those lorries on stop. So, or they're going to be on stop for a little bit, but they don't want them on stop for an hour because we're paying them. We need to be as productive and as lean, to use some manufacturing sort of terminology, as much as we can. Okay, so we basically need to work out how many vehicles we require. So basically, there's a formula: time taken to load plus the journey and tipping time. Add those together, think of your BIDMAS, I should say, divided by the time taken to load. Okay? So, excavator is loaded into 10-ton lorries. There we go. We're loading into a 10-ton lorry. Okay, rather than 16-ton, but we could use a 16-ton if we wanted to. So, convert 10-ton lorries to metre cubed is 1.6 tons per metre cubed. I've got that out of a table. Okay? So total metre cubed is 10 divided by 1.6. So those lorries will will take 6.25 meters cubed. However, as the soil comes out of the ground, it bulks because it's been there for 1,000,000 years or whatever, 50,000 years, and all of a sudden a human comes along, digs it up, and basically it's going to bulk, okay? Because somebody's been walking on it for the last 50,000 years or something, okay? So we add on a bulking factor. So 6.25 times 100 divided by 125%, because our bulking factor is 25%, will give us 5 meters cubed. So in reality, we're only excavating 5 meters cubed at a time from the ground. But actually, when we put it in the lorries, it bulks and becomes 6.25 meters cubed. So ultimately, it's 5 meters cubed that we're actually excavating. Okay? So the excavator is loading into 10-ton lorries. That's what I mean by 10 lorries there, sorry. The aim is to try and ensure the excavator and drivers are working almost as close as possible continuously. Number of vehicles required equals time taken divided by the journey and tipping time and divided by time taken to load. So what we're saying is it takes 0.17 hours, okay, to load 5 tons, okay, if you like, or 6.10 as it bulks, but 5 meter cubed, okay, which is 10 tons, okay, plus 0.53 hours. So it's the tip is 30 minutes away, basically, okay, or just over 30 minutes. If you travel something around 30 to 40 miles per hour, okay? So that's what we're saying. It would depend on how fast we go. It depends on whether it's built up traffic or it's in a rural area. It depends on how far the tip is away. You know, and then obviously you've got to maneuver whilst you're at the tip before you can tip it. So we're saying it takes about 25 minutes. By the time you get to the tip, maneuver, tip it, it takes around 0.53 of an hour. And then we divide it by the time taken to load, okay, which is 0.17. What that says to us, we need about 4.11 lorries. Now I can round that up to 5 if I want to, but I think it's so close to 4 that I've rounded down to 4 lorries. But you could even say 3 lorries, but it's going to take you a little bit longer with 3 lorries. As long as you build that into your price, that's fine. You could even, I think 5 lorries is too much because you'll have one sitting around too much. So I've said about 4 lorries. So you might have the excavator a little bit on stop, but not too much. Okay? So the driver and a 10-ton truck is £40 an hour. 4 drivers and 10-ton trucks, okay, gives us £160 an hour. 1 lorry takes 10 minutes to load. So 6 lorries times 5 meters cubed equals 30 meters cubed an hour. So we can actually load 30 meters cubed an hour. 30 meters from we take from the ground. Okay? So, but why haven't we got 6 lorries? Somebody asked me, but we don't need 6 lorries because it's a continuous. So by time that the first lorry has gone to the dumping area, okay, the tipping area, and driven, they should be driving back and being reloaded. So there's your 5th lorry, if you like, and then as they've been loaded, your 6th lorry should be coming in on around the hour. Okay, so lorry plus 1 usually. So we're saying it takes about 10 minutes a lorry to load. Okay, so that gives us 40 minutes really. Okay, to load all 4. Okay, so that's what we're sort of saying, and that's how we build it up. So I've given you how we've built it up there. Okay, so we've got £160 an hour divided by 30 meters cubed, because fundamentally that's how much we're actually disposing of, and I mean 30, that's net, what we take from the ground, not the bulk. That's how much we're taking is 30 meters cubed. So it's taking us an hour takes about 30 minutes 30 meters cubed. So we're costing £160 an hour. So that's all we do is divide that total hour by £5.33. So in effect, it's taken it's £5.33 per meters cubed. Okay. However, and this is the problem then. Okay. We've also got to include tipping charges. Okay. So we've got £150 tipping fee for inert materials. I took that off the website that was local to me in Birmingham. Okay. It can be anywhere. It depends on where you are. Depends on the local authority. And it can be anywhere between £100 and £500. Okay. So it was about 150 for inert materials. So 10 tonne is equal to 5 metre cubed. So £150 divided by 5 gives me £30 per metre cubed. So the total for removing excavated material, £5.33 plus £30 for the tipping fee, gives me £35.33 a metre cubed. And then I add on a percentage for overheads and profit. Okay? Okay, that really, I'll be honest with you, that's probably the most difficult calculation. All right? Reinforced concrete is not too bad. I've said it's a C40P. It could be C30, it could be C20, it could be C25, okay? It's a step-by-step process. This time, though, we've got plant, we've got labour, and we've got materials. So we've added on the materials now, okay? All right, so again, what resources do we need? Now, do we need a pump? Do we need a dumper? Do we include that in the preliminaries? Do we need extra labourers? Do we include that in the preliminaries? We certainly would need a poker vibrator, okay? And I would include that in the all-in rate, okay? We need labour and we need materials, including a wastage factor. So again, convert and calculate, and you should get a metre cubed rate because it's measured in metres cubed. So reinforced concrete, metres cubed, requires a poker vibrator. So we'll start with the plant first. I went online. I managed to get one for £80 a day. Okay, maybe if I hired it for 2 or 3 weeks, it would be cheaper. So I got it just for a day, £80 a day. I'm saying I'm using it for 8 hours a day. I could say I'm using it for 7.5 hours a day. It's or 6.5 hours a day if I'm doing it on Friday. It's fundamentally up to yourself. So I've just made it easy on myself. 80, so that's £8 an hour. And then the poker vibrator can only go as fast as how fast you can actually place the concrete. So I looked at some figures, and these figures change, but I chose 1.25, 1.25 hours per metre cubed. It takes about 2.5 to place concrete. I can only go as fast as I can place it. So I can only use the poker vibrator. So that's all I've done there is £8 an hour times 1.25. So it's actually costing me £10 a metre cubed. Okay. Then I need an operative or operatives for the concrete. Operative using the poker vibrator and finishing. I said, look, that's a high skill rate. It's probably going to be the ganger. So I put it at skill rate 3. So a little bit more, £21.73 times 1.25, which is your rate per hour. Okay. And it costs £27.16 per metre cubed. I've said I'm probably going to need 2 other operatives. Maybe I'm just using a wheelbarrow. They may be shoveling it in for me. I might need 3. I might need 4. I might only need 1. Again, I've left that up for you to decide. Okay, so 2 operatives, basic sort of operatives, rate for £20.70. Okay, again, I've used that, like I say, working rule agreement, the CJI skills rate. Okay, 1.25 gives you £51.75. All right. I've added those two together, the operative rate for operative rate 3, the higher skilled operative, and the two other operatives together, and it gives me around, well, it gives me £68.91 a metres cubed. Then I need some materials, and to be honest, that's all I did. I went online and had a look for some prices for C40 concrete, and I could get it quite cheap, to be honest with you, about £65.24 a metre cubed. I think it's a little bit more expensive than that, actually, but because I saw some prices out there about £130 per metre cubed. So I haven't included part loads or charges for part loads there. I've just said I need full loads basically. So £65.24 a metre cubed, and then it's a 5% wastage factor. So I've added my wastage factor on, and then it comes to £68.50 something p. I can't quite see it, sorry guys, because the video of me is in the way. So there's my material. So then for the total all-in rate, I add on the bit for the poker vibrator, I add on the bit for the operatives, and I add on the bit for the materials. And then it comes to £147.41 per metre cubed. You know, I'd say it's going to be anywhere between £150 and £250 a metre cubed. And then I add on a percentage for overheads and profit. Mesh reinforcement, measured in metres squared. One operative, high grade operative, because he's a steel fixer, so semi-skilled. 0.1525 hours. Doesn't take long to cut, move, lay and tie the sheets. £21.73. Okay, times 0.125. If you wanted to, he may need another operative to help him out. Okay, I didn't put that in, but you could add on a basic operative as well. Again, that basic operative would be something a bit cheaper, about £20.70, maybe a grade 4 operative, and then multiply it by 0.125 and then just add it on. Okay, I've just said that he can do that himself, but he may need some help. Okay, material cost then, obviously mesh reinforcement, different grades, come in sheets 2.4 by 1.2. I got that off the internet. Costs £45 per sheet. Okay, got that off the internet. 45 divided by 2.88 gives me £15.63 a metre squared. I've then said if I take laps and wastage into consideration, I've got to add on 25%, because obviously when you do mesh reinforcement, they overlap. Okay, to ensure that reinforcement it covers everything. Okay, so I've said around, let's add on about 25. Look, I could add on 40% if I wanted to. Okay, with wastage, it's just something that I've done just to show you what you've got to include. And that's £19. That sort of takes it up to £19.54. You need spacers, okay? You need tie-in wire, and again, I got all of that off the internet, to be honest with you, okay? So you know, the spacers are what they sit on. The concrete, obviously has to sit on something, otherwise it'll be on the floor, okay? And that's no good for anybody, as you can imagine. So, you know, I've just sort of added that into it as well. So a little bit of the sundry items as well, just to give it that degree of accuracy. And then I just add everything together. Okay. And again, plus your percentage for overheads and profit. Okay. Class A. So Class A would be substructure. But can I just say, it would be the same. Fundamentally, it would be the same. The same with sort of any bricks, really. You'd include, just look at the figures, those slightly different figures, okay? Okay, with regards to maybe the mortar that you're using, because the mortar that you'd use below ground, below DPC, sorry, would be a lot, much stronger, would have a higher compressive strength, and it would probably be just sand and cement rather than any lime added to it or colour added to it, because it'll weaken it. Okay, so you've got to remember that crafts people usually work in a gang of 2 and 1. That's a generalisation. So you're going to have 2 bricklayers and a labourer or an operative. Or if it's a carpentry, you're going to have two carpenters and an operative, and two electricians and an operative. So what we do here is we work it back to one bricklayer and half an operative, because a 2-in-1 gang would be 1.5. Okay, I hope that sort of makes sense. So one bricklayer can lay half a brick wall. That's a brick wall in stretcher bond. Okay, 1.5 hours per metre squared. Again, I've taken that from quite an old book, that one that I had. I think it could be a bit quicker these days, but you know, if you want to use 1.5 or 1.3, 1.4, that's fine. It would be there or thereabouts per metre squared. One labourer is shared between two bricklayers, so and therefore is going to be half the hourly, not the hourly rate, but how long it takes to lay a metre squared of bricks. So if it takes one bricklayer 1.5, it's going to take half a labourer 0.75. So you're just halving that, basically. You're dividing that, the 1.5 by 2. And then that's all you do. Bricklayer is 24.64. That's what it says in the working rule agreement, because it's a craftsperson, times 1.5, and it gives you £36.96 per square metre. Labourer, I've said a basic labourer, but you could say sometimes these labourers, particularly bricklayers, labourers, or craftspeople's labourers, will have a lot of other skills. So you can, you know, they've done a lot of training. They would be able to use a still saw, as maybe a skill saw, things like that. So you could charge more if you wanted to. I've charged the basic rate there, which is £20.70, and multiplied it by 0.75. Added them both together, and they come to around £52.49 a metre squared. So there's my labour cost. My materials: bricks class A, £500 1,000. So what we do is we get a price per brick. 59 bricks in a metre squared if you lay them in stretcher bond. Okay, which is what we're doing. So 59 times 0.5, or 50p, is £29.50 a metre squared. Add a wastage factor, about 2 to 5% for engineering bricks. Okay. Again, taking it from somewhere from a sheet I got, £29.50 times 0.05, and then add it on. Okay, gives you £30.98. However, don't forget the mortar. So mortar, with regards to stretcher bond, one brick, half a brick thick, that you require 0.027 meters cubed per meter squared. Okay. There are different ways to do it. I've done it this way to say that it's ready mixed mortar and it's come on site. Okay, and this is what they're charging you for ready mixed mortar. Okay. I could break that down even more analytically and say, we've got one guy mixing, and it takes, 15 minutes to mix enough mortar for 1 meter squared, 0.25. But what I've done is it takes 0.027 meters cubed of mortar per meter squared. All right. Which is ready mixed mortar. Okay, so it's already there. You just ready mix it. It's accurately mixed for you. You don't have to mess around with it. You know that it's accurate. It's there, a bit like concrete. You see it in a silo on site. Okay, and that's all you have to do then. The cost is £98.35 a metre cubed, and just multiply it by 0.027, and it'll give you a cost per metre squared. Add your wastage, 10%, and your rate then altogether is around £86 per metre squared. Nice and easy. And you can do that for all bricks, facing bricks. The only thing will change maybe is it might take a little bit longer to lay facing bricks. Might take a little bit less. I've kept it the same, to be honest with you. Obviously the material prices will change and the mortar prices will change, because with coloured mortar it's going to be much, much more expensive. Okay. And again, add on your profit and overheads. Okay. Okay, with blocks, it's very, very similar, exactly the same. Um, Again, with blocks, you're going to require less amount of obviously mortar because blocks take up more space. Um, you They're basically 9.8 blocks per meter squared if you lay them on stretcher bond. Okay. Um, Wall insulation can be the same as well. Okay. All right. So I'll leave you do that one. Okay. The other questions then really, that's the mathematical questions. You're building up, you're showing you how to build up a unit rate for one section in your bill of quantities. So that can be substructure, it could be superstructure. Try and do some of the complex ones as well. Try to make it accurate. It just makes it look a lot better, to be honest with you. And basically, in my previous YouTube, I sort of talked about what to add on then with regards to the written part, which is basically, look, why do estimates vary between contractors? I think that's what P8 says, I think. Um, Analyze, you know, um, the different methods used, and evaluate them, and really fundamentally, the reason things change throughout the course of the uh, um, project life cycle is because things become much more accurate, much more analytical as we move across the project life cycle and the RIBA. If I use the RIBA plan of work as my template, as we move across it, we're starting to get more information. We're relying less on historical data, and we're now relying on, when we do analytical survey, analytical estimating, we're now relying on up-to-date data. As I just said to you, look, I went on the internet to get a lot of those prices. That's the beauty these days. I can go on the internet, or I can get them from trade sort of trade magazines, from various sort of suppliers. I can use them for that as well. Those are the things that I can do, you see. It's much more up to date. I can make adjustments for the marketplace. I can make adjustments for things like part loads with concrete. If because I can be now a lot much more analytical, which I can't when I'm doing an elemental unit rate. It's more generalized when I'm doing an elemental cost plan, when I'm doing a cost estimate based on the gross internal floor area. I'm really relying on historical, quite accurate historical data, and also obviously I'm relying on the methodology set out in the NRM, which makes it reliable, consistent, certain, generalized. And what I mean by generalized is that I can compare it, okay, and it gives me all of that. However, it's going to change to ultimately the budget is going to change to the actual estimate produced by the contractor or the subcontractors, because they have to take into consideration, one, up-to-date prices, the type of contract it is, fixed, fluctuating, lump sum, target price, cost plus. All of these things will then weigh down the contractor with regards to commercial risk. And the contractors and subcontractors will take into consideration a risk element for them. And that usually is reflected not just in the unit rate and the various prices for unit rate, but also with regards to things like profit and overheads, because your general overheads are going to be more for a larger contractor, more national based contractor than a regional or a local contractor, as I said in my previous email. And that's the sort of stuff that you're writing on. The other thing I wanted to say, when we were talking about unit rates as well, you've got to remember as well, if you're a Kia or a Oh gosh, I can't think of some of the other larger contractors now, so forgive me off the top of my head. I should be able to. But if you're one of the large national, multinational contractors, you are going to be able to buy, your buying power is greater than a regional contractor's buying power. Okay? And you have much, much more integrated supply chain. So although the supply chain is going to be quite vertical, as it would be for the regional contractors, you are going to use a lot of the same subcontractors and subcontractors and material and plant suppliers. I know the regional contractors will as well, but you will, as a national contractor, you'll have a bigger pool, and therefore, if we talk in terms of basic macro and microeconomics and supply and demand, the theory is that you should be able to buy that for a lot less, because you are a bigger contractor. You know, if I'm a subcontractor and I'm working for, say, Kia's, I've got, there's less chance of you going bankrupt than, say, a local contractor. So I know that my cash flow may be a lot better with a larger contractor. Therefore, I might offer you better rates, as in I might offer you a lower rate. That might then offset the higher overheads that you have to charge. Okay, so I'm just sort of just adding that on there. Okay, so there's lots of things that you need to take into consideration with regards when you get to that point where you've, say, got 6 contractors or subcontractors submitting bids for an estimate. It's a totally different thing. Yes, you've got this very accurate bill of quantities to base your unit rates around, and you've got up-to-date prices, you've got up-to-date data, estimating data that you can rely on, that you're familiar with as an estimator that's producing maybe 2 or 3 estimates a fortnight or a month or whatever it is. You're used to doing this and you're very familiar with it. So yes, you have over that. So basically what the report is asking you, and there's more detail